Let's understand regarding the Thomson's atomic model. The first atomic model was proposed by J.J. Thompson. An atom is electrically neutral. It consists of positive charges as well as negative charges according to this particular model. Thomson assumed that an atom is a sphere of positive electricity. An atom is a sphere of positive electricity in which the electrons are embedded like the seeds in the case of watermelon. The seeds represent the electrons and the fibrous material, the massive positive sphere. So here the black colored seeds, they represent the electrons which are evenly distributed in the red colored positive part. So the red color part is the massive positive charge and the black colored seeds are the electrons, and that is the reason why Thomson's model was called as watermelon model or the plum pudding or raisin pudding model, where the raisin, whatever we are adding, they become the electrons, and the wheat flour, which becomes the mass of that plum pudding, that will become the positively charged matter. Then comes the Rutherford atomic model, because Thomson could not explain all the aspects of the atom. Rutherford performed alpha ray scattering experiment in which he bombarded tin foils of metals like gold, silver, platinum or copper with a beam of fast moving alpha particles. What he had done? Rutherford performed alpha ray scattering experiment in which he bombarded tin foils of metals, maybe like gold, silver, etc., with a beam of fast moving alpha particles. From where did he get these alpha particles? The source of alpha particles was a radioactive substance placed in a block of lead. And the presence of alpha particles at any point around the thin foil of gold after striking it was detected with the help of a circular zinc sulfide screen. So, after passing through the metal, after the metal foil, whenever we place a zinc sulfide screen, we can observe the alpha particles. The point at which alpha particle strikes that screen, a flash of light is given out. So based on the flash of the light given out, we can say that one alpha particle or a particular alpha particle is striking the zinc sulfide screen. See here. This is the source of alpha particles which is kept in a lead block, and this is the thin metal foil, and this is the zinc sulfide screen. So what happens here? Whenever alpha particles are made to fall on the metal, they move through that metal, and whenever they strike the zinc sulfide screen, we can see that flash of light. It's like this. So whenever these particles are striking the zinc sulfide screen, with the help of that flash light, we can say that the particles are striking the sulfide screen. And what are the observations? In Rutherford alpha ray scattering experiment, it was observed that most of the alpha particles passed through the gold foil without any deflection from their original path. So, most of the alpha particles passed through the gold foil without any deflection from their original path. It's like this. Is it clear? Then, what was the second observation? A few of the alpha particles are deflected fairly at large angles, while some are deflected through small angles. So, out of all the alpha particles, very few are deflecting from their original path. Like this. Then, very few alpha particles, exactly 1 or 2 in 20,000 particles are deflected back along their path, or 2 in 20,000 they are deflected back along their original path. It's like this. Then what are the conclusions? The above observations allowed Rutherford to make certain conclusions regarding the structure of the atom. It is known from the experiment that atom has largely empty space, as most of the alpha particles pass through the foil undeflected, isn't it? As most of the alpha particles are moving in a straight line without deflection, it means that atom has lot of empty space. And the scattering of alpha particles in all directions further reveals that there is a heavy positive charge at the center of the atom which cause repulsions. Why? Because we know that alpha particles are the positively charged particles, and if there is any positive charge at the center of the atom, then only that results in the repulsion of the alpha particles. So this clearly shows that atom is hollow and contains lot of empty space, and whenever the particles are coming nearer to that particular nucleus, because of the repulsion between the positive charge of the alpha particles, they are deviated to some extent. And 1 in 20,000 or 2 in 20,000, when they are coming exactly at the center of the atom, because of this objection here, they are going back. So the positively charged part at the center of the atom is known as nucleus, and the entire mass of the atom is concentrated in that nucleus only. Then, according to Rutherford, we can conclude the Rutherford atomic model in this particular way. An atom is spherical and mostly hollow with a lot of empty space in it. That's the first point. Second one, it has a small positively charged part at its center known as the nucleus, and the entire mass of the atom is concentrated in that particular nucleus. So this is the atom, the entire positive charge concentrated at the center of the atom, that is the nucleus, and the remaining atom is almost hollow. The third point, the nucleus is surrounded by the electrons, and the electrons revolve around the nucleus with very high speeds in circular paths called orbits. The next point, the number of extra nuclear electrons is equal to the number of units of positive charge in the nucleus. So number of positive charge present inside the nucleus is equal to the number of electrons which are negatively charged present outside the nucleus. And that is the reason why atoms are electrically neutral, isn't it? The electrons and the nucleus are held together by the electrostatic force of attraction. So, which is binding the electrons? The positive charge which is present in the nucleus, that is holding the electrons with the help of the electrostatic forces of attraction. Then the next point, Rutherford model has resemblance with the solar system. Just as the planets revolve around the sun, the electrons are revolving around the nucleus, isn't it? The planets revolve around the sun. Similarly here, the electrons are revolving around the nucleus, and that is the reason why the Rutherford's atomic model, that is also called as the planetary model. That's also called as the planetary model. The next point, based on the X-ray investigations, it was revealed that the nucleus has a diameter in the order of 10 power minus 13 to 10 power minus 12 centimeters, and the atom has a diameter of around 10 power minus 8 centimeters. So from this we can conclude that the size of the atom is 10 power 5 times the size of the nucleus. In the last point, there is an empty space around the nucleus which is called as the extra nuclear part, and in this part the electrons are present, and as the nucleus of the atom is responsible for the mass of the atom, the extra nuclear part is responsible for its volume. Now let's understand the drawbacks behind this Rutherford's atomic model. The first drawback, according to the modern electromagnetic theories of Maxwell, when any charged particle moves under the influence of opposite charge, it should continuously lose energy in the form of electromagnetic radiation. So what is this one? Any charged particle which is moving. So what is the charged particle which is moving here? This is the electron. Any charged particle which is moving under the influence of opposite charge, that is the nucleus which is positively charged, it should continuously lose energy. So when it loses energy, what it should happen? As a result of this, the electron should follow a spiral path and finally it should fall into the nucleus. And the ultimate result is that it will fall into the nucleus, thereby making the atom unstable. Thus, the Rutherford model could not explain the stability of the atom. And what is the second drawback? If the electrons lose energy continuously, the spectrum is expected to be continuous. Means atoms need to give always continuous spectrum. But the actual observed spectrum consists of well-defined lines of definite frequencies. Or we can say that atoms generally give non-continuous spectrum or discontinuous spectrum. So at this moment of time, it is difficult to understand the meaning of atomic spectra. In due course of discussion in this chapter, in a separate session about the atomic spectra. So for a moment, you learn like this. Atoms are expected to give continuous spectrum because they are emitting energy continuously. But actually, atoms will give discontinuous spectrum. That is the second drawback of Rutherford's atomic model.